Welcome to Math Antics. In today's lesson, we're going to learn all about factoring. Factoring is a math operation. It's something you do to a number. Now with the other math operations you've done so far, you're given two or more numbers to work with. But with factoring, you only get one number. That's because factoring is like being given the answer to a multiplication problem and then having to figure out what that problem was. So you can think of factoring as unmultiplying. When you multiply, you take two numbers and multiply them together to get one number. And when you factor, you take one number and figure out what two numbers you could multiply together to get that number. For example, let's say you're asked to factor the number 10. Now that means that you need to figure out what numbers you can multiply together to get 10. If you know your multiplication table, you'll remember that 2 times 5 equals 10. That means that 2 and 5 are factors of 10. So factors are just the parts of a multiplication problem, and factoring is figuring out what those parts are. I'm sure some of you are wondering, why would I ever want to factor a number? Now that's a good question, and I have a good answer. Factoring can make solving some math problems easier. For example, factoring is really useful for simplifying fractions. By breaking a number up into its factors, you can sometimes cancel out factors that aren't really needed. For now though, you just need to learn what factoring is and how to do it. So let's see another example. Let's factor the number 24. For this one, I think I'll use my multiplication table. Let's see here. Alright, well, 4 times 6 is 24, so that means that 4 and 6 are factors of 24. Now hold on, I'm sure some of you have seen that 3 times 8 is also 24, and that's true. We could have decided to factor 24 into 3 times 8 instead. So which of the factors is right? Is it 4 and 6 or 3 and 8? Actually, they're both right. There can be more than one way to factor a number. That's one of the things that might make factoring a little confusing at first. You're used to having just one right answer, because when you add, subtract, multiply, or divide, there is just one right answer. But when you factor or unmultiply a number, you might find that there's more than one correct way you can do it. So we can see that the number 24 has quite a few factors. 4 is a factor, 6 is a factor, 3 is a factor, and 8 is a factor. The fact that each of these numbers is a factor of 24 means that each of them can divide evenly into 24. And when I say divide evenly, I mean that it will divide in without a remainder. For example, if we take our first factor, 4, and divide it into 24 using a calculator, our answer will be 6. 4 divides into 24 6 times with no remainder. But what if we try to divide 24 by a number that isn't one of our factors, like the number 7? If we try 24 divided by 7 on a calculator, we get 3.42857 blah blah blah, a long decimal number. That didn't divide in evenly because there's a big remainder. What we just did is called testing for divisibility. Testing for divisibility is a way to find out if a number is a factor of another number. With the test we just did, we confirmed that 4 is a factor of 24, but 7 is not. Sometimes you may be asked to find all the factors of a number. If that happens, you can use testing for divisibility to solve the problem. To see how it works, let's try to find all the factors of 24. We already know 4 of them, but there's a lot more numbers we can test. Fortunately, we only need to test numbers that are less than half of the number we're testing. And since half of 24 is 12, we just need to test the numbers 1 through 12. To keep things organized, let's list the numbers we're going to test, and we'll circle the factors that we already know. 3, 4, 6, and 8. We can also cross out the 7 since we already tested it and found out it wasn't a factor. Okay, now for the numbers we haven't tested yet. Let's start with 1. Well, of course 1 is a factor, because 1 will divide evenly into any whole number, so 1 is always a factor. And since 1 is a factor, then that means that 24 is also a factor, because 1 times 24 equals 24. It might seem weird that a number is always a factor of itself, but it's true. Knowing that helps you get started listing the factors, because you can always include 1 and the number itself. Now let's move on and test 2. If we divide 24 by 2, we get 12. So yes, 2 is a factor because it divided evenly. You can factor 24 into 2 times 12. That means that we can also circle 12 as a factor of 24. So, anytime you do a divisibility test and the number you're checking passes the test, then the answer you get from dividing will also pass the test. It will also be a factor. That will speed things up because we know we don't have to test 12. Okay, let's move on to the next number we haven't checked, 5. 24 divided by 5 equals 4.8. Well, that didn't divide evenly because our answer is a decimal number. That means that 5 is not a factor of 24. Next, we'll try 9. 24 divided by 9 equals 2.66666. That's definitely not a factor. Okay, how about 10? 24 divided by 10 equals 2.4. Nope, that's a decimal number, so 10 is not a factor. It looks like the last one we have to try is 11. 24 divided by 11 equals 2.181818. That's not a factor either. Alright, since we've tested all the numbers that are less than half of 24, we found all of its possible factors, and they are 1, 2, 3, 4, 6, 8, 12, and 24. Now I know that might seem like a lot of work, but fortunately you probably won't have to do many of those problems. The important thing is just to know what factoring is and how you can use testing for divisibility to help you find factors. Alright, that wraps up this lesson, but since actually doing math is the best way to learn it, be sure.
Yes, the question here is, what is factorization? I know in your previous classes you have been taught HCF, LCM, as well as factors. So the question is, what is factorization? Well, factorization is simply the art of expressing a number as a product of its factors. I repeat, factorization is simply the art of expressing a number as a product of its factors. For example, we are going to be looking at the number 6. The number 6 has several factors. 3 and 2 are factors of 6. When we express 6 as a product of these factors, it simply means it is factorization. So, when we express 6 as a product of 3 and 2, we have 3 times 2 equals to 6, or 2 times 3 equals to 6, which is factorization. So we can say that the factorization of 6 is equal to 3 times 2. Then on the other hand, factors, they are numbers that divide another number without leaving a remainder. Factors, they are numbers that divide another number without leaving a remainder. I'm going to be taking an example to explain this. For example, you are asked to write out the factors of 12. You are asked to write out the factors of 12. You will notice that all the factors of 12, that is all the numbers that can divide 12, are 1, 2, 3, 4, 6, and 12. All these numbers can divide 12 without leaving a remainder. So this is what makes them to be factors of 12. So I'm going to be explaining to you the different methods of factorization. First, I'll be explaining factorization by HCF, factorization by HCF. So what is HCF? You already know the meaning. HCF means highest common factor. Highest common factor. So in this particular set of examples, we'll be using the highest common factors to solve factorization. So let's take the first example. It says, find the HCF of 8PQ and 24P squared. HCF of 8PQ and 24P squared. So what do you do here? All you just need to do here is to express each term as a product of its factors. Express each term as a product of its factors. For 8PQ, you have 2 times 2 times 2 times P times Q. Then for 24P squared, you have 2 times 2 times 2 times 3 times P times P. So you trace out the common terms. I mean the common factors. If you look at it carefully, you notice 2 times 2 times 2 times P are common. So that gives us our HCF as 8P. Now, this is a class activity. I need you to solve this class activity in your notes and submit to your teacher. It says, find the HCF of several MNP and NP. So let's take the next example, which is example 2. This example says, factorize 2mh minus 8m square h. 2mh minus 8m square h. So how do we go about this? The first thing you need to do is to find the HCF of the terms in the given expression. So you're going to look for the HCF of 2mh and 8m square h. And if you do that rightly, you will discover that the HCF is 2mh. So what do you do with this 2mh? You use this 2mh to divide each term in the expression, but take note, you will retain the HCF. So when you do this, you have 2mh in the bracket of 2mh over 2mh minus 8m square h over 2mh. Then this will give us 2mh. After dividing, you have bracket 1 minus 4m. So final answer is 2mh bracket 1 minus 4m. You can see it's very, very easy. Again, I need you to try this second class activity in your note and submit to your teacher. It says, factorize 5a cubed minus 3a, just complete it yourself. Example 3. It says, factorize the following expressions. Factorize the following expressions. A, 2x in the bracket of 5a plus 2 minus 3y in the bracket of 5a plus 2. Then the second question is 2d cubed plus d squared in the bracket of 3d minus 1. So I need you to pay attention to this particular type of example. Very, very important. So in the very first one, you will notice that there is a common factor. And what is the common factor? 5a plus 2. The bracket of 5a plus 2 is common to both sides of the expression. So it means that if we bring out this common factor, we now have 2x in the bracket of 5a plus 2 minus 3y in the bracket of 5a plus 2 to be equal to what? Bracket 5a plus 2 bracket 2s minus 3y. I told you it's very, very simple. You can try more on your own. Then we have the second problem here, which says we should factorize it. But if you look at the expression carefully, you notice that d squared is a common factor to the expression. So what do? You bring out the d squared and write down whatever is left in the bracket. So what am I trying to explain here? You have d squared in the bracket of 2d plus bracket 3d minus 1. So you open the inner bracket and you have d squared in the bracket of 2d plus 3d minus 1. 2d plus 3d will give us 5d. So our final result is d squared in the bracket of 5d minus 1. Quite simple. Now, this is another class activity I need you to solve. You can always pause the video to write down the question so that you can solve. It says, factorize d in the bracket of 3h plus k minus 4d squared. Now, another method we can use in factorization is factorization by grouping. What did I say? Factorization by grouping. Here, your main emphasis is to group before you factorize. So let's take a look at this example. Example 4. It says, factorize 2s ROU plus 6t ROU minus 4s ROV minus 12t ROV. So the first thing is you check if there is a common factor to all of them. So if there is a common factor, you bring out that common factor first before you proceed. So let's quickly take a look at the expression again. If you take a look at the expression carefully, you will notice that there is a common factor of 2r. It's common to all the terms in the expression. So that gives us 2s-ROU plus 6t-ROU minus 4s-ROV minus 12t-ROV to be equal to what? 2r. Now we are left in the bracket. SU plus 3TU minus 2SV minus 6TV. So the next thing you are going to do now is you group the terms in the bracket. You are going to group the terms in the bracket so that you can factorize again. Yes, at times you can factorize more than once. So when you group the terms in the bracket, you have bracket SU plus 3U minus bracket 2SV plus 6TV. Don't forget that minus minus is plus, so that's why the sign now changed to plus in the second bracket. So find out what is common in the group bracket. When you find out what is common in the group bracket, you discover that in the first bracket U is common, while in the second bracket 2V is common. So if you do that, you will notice that there's also another common factor of bracket X plus 3T. So bring out that common factor and you have your final answer as 2r in the bracket of S plus 3T bracket U minus 2V. So I need you to try this last class activity, solve it in your maths note and submit to your teacher. I hope you enjoy this lesson. I will be with you in the next one. Thank you.